Hey guys, and welcome to your video notes 4.3, Analysis of Functions, Part 3. So here we're going to sketch functions given all of their properties of interest. Keep in mind that not all of the properties listed above are useful for every type of function. So let's do this one example together. This one example does not cover every type of graph that's going to happen, but I think it'll get us a general idea, and then you can practice more in your weekly homework. So looking at this function here, first, this function has critical values, right? So what are the critical values of my numerator telling us? That's telling me my x-intercepts. And if I set that numerator equal to 0, my x-intercepts are at plus or minus 1. So now if I set my denominator equal to 0 for that critical value, it's telling me my vertical asymptote, which is at x equals 0. So for calculus-based problems, in order to find horizontal asymptotes or end behavior, even though we can figure it out using properties we've learned from previous classes, let's use properties of calculus. So end behavior for a function in calculus is a limit. The limit as x approaches positive infinity of f of x is 0. And the limit as x approaches negative infinity of f of x is also 0. So therefore, we have a horizontal asymptote at y equals 0. So that is how we can use our critical values of our original function to find points of interest. So we have our x-intercept, our vertical asymptote, and our horizontal asymptote so far. All right, so let's move on to the second video now to determine the critical values of our derivative.